Sketch the graph of a function that satisfies all of the given conditions. So this one's a little bit tricky because it does not give you an equation. Instead, it gives you a bunch of conditions, and from these conditions, you need to try to draw the graph. So let's see if we can dissect these conditions to figure out what they're trying to tell us. So this one right here, this very first one, it says f of 0 equals 4, f of 2 equals -2, and f of 4 equals 1. So what is that trying to tell us? Well, it's trying to give us some coordinates. It's trying to give us some points we can use. So f of 0 equals 4. That means when x is 0, y is 4. F of 2 equals -2. So when x is 2, y is -2. And f of 4 is equal to 1. So when x is 4, y is 1. So that's pretty helpful. It gave us some nice coordinates. Let's go ahead and plot those. So we have x is 0, y is 4. We have x is 2, y is -2. And we have x is 4, y is 1. There we go. So that was helpful. That gave us some good points. Let's see what else we've got. So the second line right here says f prime of 0 equals f prime of 2 equals f prime of 4 equals 0. So this means that our derivative is 0 at 0, 2, and 4. So that's telling us our critical numbers. And that's telling us our critical numbers are 0, 2, and 4, meaning that our first derivative is going to be 0 at each of these places. Well, that's giving us enough information for our first derivative test. So for our first derivative test, we know that we're going to be splitting at 0, 2, and 4. All right, well, that's going to give us our intervals. We don't know what's happening in our intervals yet, but we have intervals. So let's see if we can figure this out. So we have 0 here, this will be 2, and this will be 4. So this will be -infinity to 0, 0 through 2, 2 through 4, and 4 through infinity. There we go. Let's keep reading. Next line, it says f prime of x is greater than 0 if x is less than 0 or 2 is less than x is less than 4. Well, what does that mean? The first derivative is greater than 0. The first derivative is greater than 0. That means it's positive. So this is telling us that the first derivative is positive when x is less than 0 and when x is between 2 and 4. So that means these two intervals, we have our positive first derivative. Look at the next line. The first derivative, f prime of x, is less than 0. Well, that's telling us the first derivative is negative. If x is between 0 and 2, excuse me, or x is greater than 4. That's telling us our signs. And now we can do our increase, decrease, increase, decrease. But then look over here. We're given x is 0, but we were already told when x is 0, y is 4. We found x is 2, but we were already told when x is 2, y is -2. And we found 4, and we've already told our coordinate was 4, 1. So this is our max, this is a min, and this is our max. So we've been given indirectly quite a bit of information here. Go down to the next one. Double prime. I'm going to switch colors because now we're on our second derivative. F double prime of x is greater than 0 if 1 is less than x is less than 3. What does that mean? The second derivative is greater than 0. Second derivative is greater than 0. Well, that's telling us our second derivative positive. Okay, let's try it. I'm going to do my second derivative test over here. So I have my interval, I have my second derivative, and we'll be looking at concavity. Well, it's giving me some information here. It's told me that we have 1 and 3 as an interval. So 1 and 3 to give me 1 and 3 as an interval. So So that means I have to have another interval from 3 to infinity and another interval from negative infinity to 1. And this piece right here is telling us the second derivative is greater than 0. That means it's positive. And the last piece right here is telling us the second derivative is less than 0. So that means the second derivative is negative when x is less than 1. So that's our first interval here, or x is greater than 3. Now we've got our concavity. So while it was a little bit indirect, it was very indirect actually, we were given quite a bit of information here to let us be able to fill in our first derivative and our second derivative charts. And if we can do our charts, we can do our tests, which means we can draw our graph. So let's see what we can do here. This is supposed to be a max right here at 0, 4. Okay. It is going to be increasing into it. So that's going to look like this. And then we've got to get down here. And then we've got to get back up here. Now notice I can't write my coordinates here because I don't know my y values. And so I can't write the coordinates. So I can just do the best I can to eyeball it. I can't write the exact location like I normally like to do. But we can eyeball it. And it looks like this is going to be what our graph looks like. And we know it's concave down. There we go. So it looks like here's our sketch of our graph based on the given conditions.